The world of prosthetics is changing. What was once a field limited to basic functionality has now evolved into a realm of incredible innovation and possibility. The advancements we are witnessing today are nothing short of revolutionary. We are moving beyond simply replacing a limb. Today's prosthetics are designed to integrate seamlessly with the human body, offering not just movement but a sense of touch and control that was previously unimaginable. We are now creating limbs that act and feel real. These advanced prosthetics can mimic the natural movements of human limbs, allowing users to perform delicate tasks with precision and ease. Imagine a child picking up a toy or an artist painting with a prosthetic hand. This is possible because of amazing advances in technology. We use robotics, artificial intelligence, and sophisticated sensors to create prosthetics that can respond to the user's thoughts and movements almost instantaneously. And bioengineering to build these new limbs. Bioengineering allows us to integrate living tissue with mechanical components, creating prosthetics that are not only functional but also biologically compatible with the human body. These technologies are giving people new hope. For many, the ability to regain lost functionality means a return to independence and a significant improvement in quality of life. They offer a future where limitations are minimal. People can now run, bike, and engage in sports with prosthetics that are designed for high performance. This opens up a world of possibilities for those who once faced significant physical limitations. For many years, those who lost limbs had limited choices. Early prosthetics were often cumbersome and uncomfortable, offering little more than basic functionality. They had to adapt to a life that was often difficult. Simple tasks could become monumental challenges, and the emotional toll was significant. But technology is changing this story. Modern prosthetics are not just tools. They are extensions of the human body designed to enhance and empower. We are entering a new era of prosthetics. This era is characterized by rapid advancements and a focus on improving the user experience. This era promises better functionality and a better quality of life. With continued innovation, the future of prosthetics looks brighter than ever, offering new possibilities and hope for millions around the world. Robotic limbs are key to this new era. They are complex machines. They are designed to mimic the movements of real limbs. These limbs use motors, sensors, and actuators. These parts work together to provide a wide range of motion. Early prosthetic limbs were simple. They offered limited movement, but today's robotic limbs are very advanced. They allow for more natural and fluid movements. This helps people perform everyday tasks with greater ease. Artificial intelligence is making prosthetics even smarter. With advancements in technology, these smart limbs are now capable of performing tasks that were once thought impossible. The integration of AI allows these prosthetics to not only mimic human movements, but also to learn and adapt over time, providing a more natural and intuitive experience for the user. AI helps limbs learn and adapt to the user's movements. This adaptive learning process involves the prosthetic limb collecting data from the user's daily activities and using this information to improve its functionality. Over time, the limb becomes more attuned to the user's unique movement patterns, making it easier to perform complex tasks with greater ease and precision. This means the limb can anticipate what the user wants to do. By analyzing brainwaves and neural signals, the prosthetic can predict the user's intended actions and respond accordingly. This predictive capability is crucial for tasks that require quick reflexes and fine motor skills, such as picking up small objects or adjusting grip strength. This makes the movements smoother and more precise. The AI algorithms continuously refine the limb's movements, reducing any jerky or unnatural motions. This results in a more fluid and natural experience for the user, allowing them to perform everyday activities with confidence and ease. AI also helps process sensory information. The sensors embedded in the prosthetic limb collect data from the environment, such as temperature, pressure, and texture. This sensory feedback is then processed by the AI to provide the user with a more comprehensive understanding of their surroundings. This information comes from the environment. By continuously monitoring and analyzing environmental data, the prosthetic limb can make real-time adjustments to its movements. This is particularly useful in dynamic settings where the user needs to navigate through different terrains or interact with various objects. The limb can then adjust its grip or movement. For instance, if the sensors detect a fragile object, the AI will adjust the grip strength to prevent damage. Conversely, if a heavier object is detected, the grip strength will be increased to ensure a secure hold. For example, AI can help a prosthetic hand adjust its grip. This adaptability is essential for performing a wide range of tasks, from cooking and cleaning to more delicate activities like writing or using electronic devices. It can tell the difference between a delicate egg and a heavy book. This level of precision and adaptability not only enhances the user's ability to perform everyday tasks, but also significantly improves their quality of life, making smart prosthetics a revolutionary advancement in assistive technology. Bioengineering is another exciting area. It represents the cutting edge of science and technology, where the boundaries between biology and machinery blur. Researchers in this field are constantly pushing the envelope, exploring new ways to enhance human capabilities and improve quality of life. From developing advanced prosthetics to creating biohybrid systems, the possibilities are endless. One of the most promising areas of bioengineering is the integration of prosthetic limbs with the human body. This isn't just about creating a mechanical replacement for a lost limb, it's about making that replacement feel as natural and functional as possible. The goal is to create prosthetics that are not only physically integrated, but also seamlessly connected to the user's nervous system. This integration can often be achieved through surgical procedures. Surgeons work meticulously to ensure that the prosthetic limb is securely attached and that it can function in harmony with the rest of the body. These procedures are complex and require a high level of precision and expertise. One such method is osseointegration, where the prosthetic is directly attached to the bone. This technique provides a stable and secure connection, allowing for better control and comfort. Osseointegration has been a game-changer for many amputees, offering them a new level of mobility and independence. The result is a prosthetic limb that feels more like a natural extension of the body. Users can walk, run, and perform daily activities with greater ease and confidence. The improved fit and functionality can significantly enhance their quality of life. Another exciting area of bioengineering is the connection of prosthetics to the user's nervous system. By linking the prosthetic limb to the nerves, scientists aim to enable users to control the limb with their thoughts. This involves complex neural interfaces and advanced signal processing techniques. Imagine being able to move your prosthetic arm just by thinking about it. This level of control can make a huge difference in the user's ability to perform tasks and interact with their environment. It brings us one step closer to truly merging man and machine. But the advancements don't stop there. Researchers are also working on ways to provide sensory feedback from the prosthetic limb. This means that users could potentially feel sensations such as touch, pressure, and temperature through their prosthetics. Imagine feeling the touch of a loved one's hand on your prosthetic hand. This kind of sensory feedback can greatly enhance the user's experience and emotional connection to their prosthetic limb, making it feel even more like a natural part of their body. Section 5. Success Stories, Advancements in Action. We've seen amazing progress in prosthetics. There are many stories of people who have benefited from these advancements. One such story is that of a musician who lost his arm. He was fitted with a prosthetic arm that allows him to play the violin again. There's also the story of a double amputee. She can now run and dance, thanks to her advanced prosthetic legs. These stories highlight the transformative power of these new technologies. Section 6. The Ethical Considerations. As we continue to push the boundaries of prosthetic technology, we must also consider the ethical implications. For example, we need to make sure that these technologies are accessible to everyone who needs them. We also need to think about the potential risks of these technologies. What happens if a prosthetic limb malfunctions? These are important questions that we need to address as we move forward. Section 7. Challenges on the path to a seamless integration. Despite the incredible progress, challenges remain. One challenge is the cost. Advanced prosthetics can be very expensive. This limits access for many people. We need to find ways to make this technology more affordable. Another challenge is durability. Prosthetics need to withstand the wear and tear of everyday life. we need to develop materials and designs that are both strong and lightweight. Section 8, a future without limitations, hope and possibilities. The future of prosthetics is full of hope and possibilities. As we continue to innovate, we can create limbs that are even more lifelike and functional. Imagine a future where prosthetic limbs are indistinguishable from real limbs. This is the future we are working towards, a future where technology empowers people to overcome any physical limitations.